Hello everyone, welcome back to our channel. Today I want to share with you system of particles and rotational motion short answer questions. So from the board of intermediate, this chapter is very important. We are expecting short answer from this chapter. In this we are giving more preference to what is the center of mass. Our first short answer question is what is the difference between center of mass and center of gravity. For knowing about it, we know the basic definitions of what is center of mass and what is center of gravity. See, total mass of the body is concentrated at a single point, that is called the center of mass. Suppose you are taking this marker. Where is the center of mass? Center of mass is here at the center. If you are taking the square where the diagonals are coincide, that is the center of mass. If you are taking the triangle where the vertices are coincide, that is the center of mass. So the total mass of the body, even human being also, total mass is concentrated at a single point. So total mass is concentrated at a single point, that is called the center of mass. What are the examples for this? Look here. One side I am taking center of mass, another side I am taking center of gravity. See, when we are taking circle, this is the center of mass. When you are taking the triangle where the vertices are coincide, this is the center of mass. So like any body, the total mass is concentrated at a single point, that is called the center of mass. Like that, what is the center of gravity? For knowing about the center of gravity, what is the weight? You know that mass into acceleration due to gravity is called the weight. In previous videos, I have given physics in our daily life. What is the weight and mass? I have given complete explanation. If you want to follow, please follow that video. You will get the clarity on mass and weight. Anyway, come back to our question. See, what is the center of gravity? Total weight of the body is acting through a single point, that is called the center of gravity. Look here. Suppose you are taking the circle. Total weight is acting like this. Mass into acceleration due to gravity. Like that, any shape of the body. You are taking this body. Weight is acting downwards. See, total weight is acting through a single point, that is called the center of gravity. Now, second difference is, you know that weight formula is mass into acceleration due to gravity. So center of gravity is depends on the acceleration due to gravity. But the center of mass is quantity of matter. It does not depends on the acceleration due to gravity. Then third one, in the case of uniform bodies like rectangle, square, circle, then any rod, all homogeneous bodies, center of mass is coincides with the center of gravity. Suppose we are taking another shape of bodies, like look here. We are taking big body. Then what happens? Center of gravity does not coincide with the center of mass. Center of mass is heavier side. Don't expect here at the center. Always it is at heavier side. Suppose you are carrying the two bags. One is having the 10 kgs. Another one is having the 5 kgs. Where the center of mass is shifting, always it is heavier side, means it is shifting towards the heavier side. So in the case of homogeneous bodies, center of mass and center of gravity are coincide. But in the case of uneven bodies like rocks and all this, what happens? Center of mass is shifting towards the heavier side. So these are the differences between center of mass and center of gravity. Then come to our next short answer. See, show that system of particles moving under the influence of external force. So we are taking one system that is having the number of particles. We should consider n number of particles, and what we have to show that it is moving under the influence of the force. For this we can concentrate on what is the motion of center of mass. How to discuss the motion of center of mass. See, position of center of mass is m1 r1 plus m2 r2 plus and so on mn rn divided by total mass of the body is m. From the coordinates of center of mass, r we are considering displacement of center of mass. This r1 is the displacement of first particle, r2 is the displacement of second particle. Like that we are taking the n number of particles. From this, differentiate above equation. Now rate of change of displacement what we are calling velocity. So it gives the velocity of center of mass. Here also d by dt of r1 plus m2 into d by dt of r2 plus and so on mn d by dt of r. As usual we are taking by m. Now you look here. Rate of change of position. Position is nothing but displacement of center of mass. It gives the velocity of center of mass. Here m1. This is the velocity of first particle, second particle, so on mn vn divided by n. Now when you are differentiating above equation, rate of change of velocity is giving what? Acceleration. So m1 into d by dt of, we can't apply the differentiation to the mass. Mass is the constant, equals to v1 plus m2 into d by dt of v2 plus and so on mn into d by dt of vn divided by total mass of the body is m. So rate of change of velocity is called the acceleration. You can take it ACM equals to m1a1 plus m2a2 plus and so on mn an. When we are doing the cross multiplication, MACM equals to, instead of M1A1, F1 plus F2 plus and so on Fn. So finally conclusion is, look here, see this ACM equals to acceleration of center of mass. It depends on the total external force by mass. So this is the proof why show that system of particles moving under the influence of the external force. Third answer is very interesting topic. Daily we should observe that, and we know that moon is always revolving around the earth. Moon is the natural satellite of the earth. Why moon is revolving around the earth? Why earth is not revolving around the moon? See, when we are observing that mass of the earth is 81 times greater than that moon. So center of mass is what? Towards nearer to the earth. So location of the center of mass is nearer to the earth. That's why moon is always revolving around the earth. Then the only force acting on that, the only external force acting on this system is the sun. Sun is huge comparing with these two. That's why around the sun, this earth and moon system is having the elliptical path. Look here, this is the sun, this is the earth. In this orbit moon is revolving. Why moon is revolving? This mass is, earth mass is 81 times greater than that moon. That's why center of mass is nearer to the earth. When we can go through the, when we consider the sun, what happens? The external force is due to the sun. That's why the entire system is having the elliptical path around the sun. Then our next short answer is, define the cross product. Define the cross product and write the properties. First of all, what is the cross product? It is the one of the method to multiply the vectors. That is called the cross product. How to define this one? For this we are taking two vectors. Look, P bar cross Q bar. We can call this is the vector product, is equals to, definition, product of magnitude of two vectors. Magnitude is of P represented by mod of P bar. Product of magnitude of two vectors and sine of the angle between them along with unit vector. What it represents? N cap is the unit vector. So after doing this multiplication cross product, our answer is in terms of vector. So once again I want to say that this is the product of magnitude of two vectors, sine of the angle between them along with unit vector. Then we should focus on what are the properties. See, it does not obey commutative law. Does not obey commutative law. What is the commutative law? Generally you can say AB equals to BA. But it is cross product. We should write it A bar cross, otherwise P you can take it. P bar cross Q bar is not equals to Q bar cross P bar. So it does not obey the commutative law. But P bar cross Q bar equals to minus q bar cross p bar. Then next property is it obeys distributive law. It obeys distributive law. What is the distributive law? P bar cross q bar plus r bar is equals to P bar cross q bar plus P bar cross r bar. This is the distributive law. Next property is when we are taking the reference frame coordinate system along the x-axis, y-axis, z-axis. I cap is the unit vector along the x-axis. J cap is the unit vector along the y-axis. Then k cap equals to unit vector along the z-axis. When we are writing I cap cross I cap equals to J cap cross J cap equals to K cap cross K cap is equals to how much? 0. Why? Between two same vectors, angle is the 0, sin 0 equals to 0. That's why cross product of same vectors is equals to 0. Whenever any two vectors are parallel to each other, what do you say? That resultant, that cross product is equals to 0. Then when we can go through the anti-clockwise, see I cap cross J cap equals to K cap. Then J cap cross K cap equals to I cap. K cap cross I cap equals to J cap. When we are taking reverse order, we are getting the minus K cap. K cap cross J cap equals to minus I cap. And K cap cross reverse we are taking I cap cross K cap equals to minus J cap. Then example for this, angular momentum L bar equals to R bar cross P bar and velocity V bar equals to R bar cross omega bar. These two are the examples. If you want to take torque tau equals to R bar cross F bar also. These are the examples for the cross product. It is very, very important. First answer also, difference between center of mass and center of gravity. This one is also very important. Then our further question is, look, here our next short answer question is, define angular velocity and derive the relation between angular velocity and linear velocity. Look here, angular velocity is the omega, linear velocity is the v, and r is the radius. First of all, what is angular velocity? You know that when you are running and a bike is there, all are having the speed or velocity. In linear motion, we can call that is the linear velocity. Like that, when the body is rotating, see our fan is, any fan is there at room, you can observe that fan is rotating, but that is having the speed or velocity, but we are calling that is called the angular velocity. Angular velocity is represented by omega. How to define the angular velocity? See, rate of change of angular displacement. Angular displacement is nothing but theta. See, angle subtended by the arc at the center, that is called the angular displacement. So rate of change of angular displacement is giving the angular velocity r. It should be right. This is the instantaneous angular velocity, delta theta by delta t. Change in angular displacement to the time interval is called the angular velocity. Unit for this one is the radians per second. But another part is derive the relation between v equals to r omega. Look here, we know that angular just now omega equals to d by dt of theta, but theta equals to x by r. X is the linear displacement, so omega equals to d by dt of omega equals to d by dt of x by r. Here r is not changing. Why? It is constant radius, so omega equals to 1 by r into dx by dt. 1 by r into dx by dt. Now omega equals to, you know that rate of change of displacement is called the linear velocity. This is linear displacement, this is angular displacement. This is angular velocity and this is the linear velocity. Don't confuse. Finally we are getting V equals to R omega. This is the relation between linear velocity and angular velocity. So basic we should remember that the rate of change of angular velocity, angular displacement is called the angular velocity. Then instead of theta we are writing x by r, linear displacement by radius. But r is constant when we are doing the differentiation. Dx by dt is nothing but linear velocity. So this is the relation between these two. Now our next question is, what is that? Same, define angular acceleration. But the thing is, we should give the relation between tau and alpha. Tau is the torque and alpha is the angular acceleration. Look, alpha equals to rate of change of angular velocity. Just now you know that what is angular velocity. Differentiation of angular velocity is giving the angular acceleration. Then from the Newton's second law, force equals to, what is the formula? Rate of change of momentum. Force is the rate of change of momentum. So here instead of torque we are taking rate of change of angular momentum. Rate of change of angular momentum. So tau equals to d by dt of, instead of L we are writing I omega. So tau equals to, I is constant, d omega by dt. Just now we know that angular acceleration, it is represented by I alpha. So tau equals to I alpha. Then our next question is, write the rotating equations of motion of rotating motion. So you know that 4 equations of motion in linear motion. See, first one is the v equals to u plus at. Here linear final velocity, angular final velocity is the omega equals to omega naught plus, instead of linear acceleration we are taking angular acceleration. Then second one, s equals to ut plus half at square. Instead of s, theta omega naught into t plus half into alpha into t square. Don't confuse. Instead of linear displacement we are getting the angular displacement. Instead of linear acceleration we are getting the angular acceleration, because we are familiar with this one. In exam no need of writing this linear and this. Then third one, v square minus u square equals to 2as. Instead of v square, final angular velocity square minus initial angular velocity square, 2 into, instead of acceleration, angular acceleration alpha, this is the theta. Like that, fourth equation of motion, Sn equals to u plus a by 2 into 2n minus 1. So instead of initial velocity omega naught, alpha by 2. Time is scalar, no need of changing that. So finally you can write it. Look here, I am putting the star mark. This one, this one, this one, this one, we should write it. When we can take the comparison, no, easily we can write it. So this is very important for short answer. Don't leave this chapter. It is very simple chapter and easily we can learn the answers. Thank you. Please subscribe my channel.